did. The final is the same values, but now the cos is 90. Why is 90? Because we have the magnetic fields and the coils, and the normal there, it is at 90 degrees to one another. So that answer will give us 0, because cos 90 is 0. Then, here the same values, but now the cos is 0. Why? Because the normal and the magnetic fields are parallel to one another. So it means that the angle between them is 0, and that gives you, I believe you, you got that?
When it's parallel, is it always going to be 0?
When the normal force and the magnetic fields are parallel, yes.
It's like when they tell us.
Like they did now here. This is solenoid starts in position where where the solenoid is perpendicular to the magnetic field. Then that's 0. Because they didn't say the normal is perpendicular, they said the solenoid is perpendicular to the magnetic field. So what do you do then? You take your solenoid, your coils, and you draw in a normal, that's 90 degrees. And then you see where's your magnetic field lines. Okay, yes. I'll be with you right now. Okay, right, so now we got the change in magnetic flux. Now, you do not have to show with calculation that the first one is 0. Okay, you could have seen that it is 0, then you could have just written the first, after the final magnetic flux is 0. Okay. So now we are going to write, we want the volts, the EMF, electromotoric force, is negative the number of coils, the change in magnetic flux over the change in time. Right, the number of coils in 150, the change in magnetic flux, change is always final minus initial. So it is 0 minus 8.174 times 10 to the power negative 8 over, and they tell us the time is 3.2 times 10 to the power negative 2. .83. And the unit? Volts. EMF volts. So this question will count about 5 marks. Okay, so where will your 5 marks go? For formula substitution, not answer. And then formula substitution, answer. Okay. Right. Now it says, a certain spiral coil has a radius of 0.3 meters and contains 20 turns. In position 1, the magnetic field due to the magnet is positive 0.3 MT. Millitesla. So do we work in millitesla? No, we work in Tesla. When the magnet is pulled out, the field changes to negative 0.2 millitesla in 1.5 seconds. Calculate the average induced EMF, so volts, in the coil over time. Alright, info table. They say there, the radius is 0.3 meters. What are we going to do with the radius? How do you get the area? You want the area is pi r squared. Oh, so pi times 0.3 squared. And that gives you what? 0.2827 Ooh, I won't have enough space. 28274. Remember, it's not your final answer, so you do not round off just yet. Alright, then they say the number of turns is 20. They say initially at position 1, the strength of the magnetic field, so B, is 0.3 millitesla. Okay, we said we don't work in milli, we work in Tesla. How do we go from milli to normal? Okay, sorry, that is initially. Then at the end, it is negative 0.2 millitesla, again times 10 to the power negative 3. The time is 1.5. Fatima, didn't you say you'll go to the optometrist?
I already went.
And what did they say?
I mean, no.
No one. It's not normal to go like this. Okay. They say the time is 1.5. Calculate the average induced EMF. So they want the E over time. Okay. So again, they did not give us the magnetic flux or the change in magnetic flux. They gave us a magnetic field, B, Tesla. So you must first go calculate the magnetic flux before you can calculate the induced EMF. Okay. Will we have in both positions, will it have an effect? Yes, because it's in and out like this. It's not an in and like that. Okay, so we must calculate both. Okay, so let's get the flux at the beginning is BA cos of theta. 0.3 times 10 to the power negative 3. The area, we got a 0.28274 times the cos of 0 degrees. Okay, let's just go over this cos 0 degrees again, because ma'am, it looks kind of perpendicular to me. Where must it be? I'm going to zoom in. If that is my coil there, then I must draw in a normal perpendicular to my coil. You'll see normal is always a dotted line. So there's my normal perpendicular to my coil. And then so that is my first step. And then I ask myself, alright, if my normal is there, where or how does the magnetic field produced be relative to my normal? So you can see there's my magnetic field go around like this. Yes, and around like this. The field lines. Whoosh. So it goes in there and around. So it means the field lines of this magnet, is parallel to my normal. Are you with me? So then the angle is 0 degrees. Sharp. Alright, so for that first one, what did you get? That's what? Say again, 8. I get 2. I think, did you round off there? Not. I get 8.422. It won't make such a big difference, but I get 2. I did not round off anyway. Check. Alright, remember, it's always, as you see, it's always good to check me. I am 100% human. Alright, then I want the final one. So it's BA cos of theta. What did we get there? It's negative 0.2. Negative 0.2 times 10 to the power negative 3. What did you get, Tazwa? Not for this answer, for the previous one. Did you redo it?
Yeah, I did. It's 2, 3.
Did you put in your pi sign?
Yeah.
Oh, I see. I think so. Yours will then be more accurate than mine, because I didn't leave in my pi sign, I took it to decimals. But it will not be such a big train smash. Okay, and then I get negative 5.654. Okay, right, so that is what I got for both of them. So we have the final, we have the initial. Please, you must stop me if you have a question. Ma'am, why did you put in this? Why did you do that? Can you please explain again? Then we want the EMF is the coils over the turns of the change in magnetic flux times the change in magnetic flux over the change in time. The number of turns was 20. Final was negative 5. I need to move this up a bit. 5.654 times 10 to the power negative 5 minus 8.48 10 to the power negative 5 over the time they said is 1.5 seconds. Ooh, what did I type in? Oh, yeah. Did you get the answer? 1.87? 8? Let me see what I wrote. This thing. I think that answer is from the textbooks. I think that answer will be very rounded off. It's minus 5 there at the top, no? Yeah, I get 1.88. And the unit is volts. Hallelujah. Okay, next year I'll leave a bit more space open for the learners doing this. Alright, so so you can see the next 4 pages are all past papers. You can see I took the multiple choice, so for November 2015 I took the multiple choice of that year and then the longer question, then the multiple choice, longer question, multiple choice, longer question. And that will be your homework. Let's do November 2015 and November 2017. Okay, so the whole of page 8 and the whole of page 9. Right, you can start.